Okay, so let's scoot on. Let's talk about mathematical models and building functions. So let's look at this first example. It says, let the point P, xy, so it's a generic point, be on the graph of y equals x squared minus 3. So we know that we have a graph of a parabola, as a matter of fact, if you remember that the squared. And we know that there's this arbitrary point xy that's actually on this graph. Okay, so look at part A. Part A asks us to express the distance d from P to the origin. And I know the last part says as a function of x, but they want us to express the distance from P to the origin. So I guess first things first, I guess we need to remember what the distance formula is between 2 points. Because technically, P is a point, which is xy, and the origin is a point, which is 0, 0. So, do you remember the distance between 2 points? If you don't, here it is. And by the way, I promise, this formula was not pulled out of the thin blue air. It is based on Pythagorean theorem. And I think I'll talk about it a little bit later in one of the other sections. So just stay tuned. So this is the distance between 2 points. I need to know 2 x's and 2 y's. And so I have 2 x's and 2 y's because I have these 2 points. Good? Okay, so if we go ahead and plug those in, then I have x minus 0 in parentheses squared, and then I have y minus 0 also in parentheses squared, and then I have the square root of x squared plus y squared. Agreed? So I have found the distance between 2 points, haven't I? Now, question for you. Do any of you think that this d equals the square root of x squared plus y squared, do any of you think that it could reduce down to x plus y? I know some of you said yes, some of you said no, and some of you are like, I don't know, sounds about right. Here's the deal. This addition sign acts like superglue. X squared and y squared are stuck together like superglue. I cannot look at them separately. If there was multiplication between them, such as this example, d equals the square root of x squared times y squared, the multiplication in between will allow me to split these up and take the square root individually. However, this addition sign will not let me do that, which means it does not allow me to take the square root of x and the square root of y and add them together. So our distance would be the square root of x squared plus y squared. Good? Remember, only multiplication and division allow me to look at things separately. Now, we took care of the first part. They said find the distance from P to the origin. But this last part says as a function of x. And you're like, what's that mean? Well, let me rewrite what we got. And since they said as a function of x, they mean d of x, which means the only variable I'm supposed to find on the right side of this equal to sign is x. I've got x squared, so I'm okay with that. But that y is not allowed. Are you with me? That y is not allowed. So I need to find a legitimate substitution for y that is in terms of x. Do you notice this equation they gave us? They say y equals x squared minus 3, right? So, since y equals x squared minus 3, making sure it was a minus sign, then I can write this as x squared minus 3 to the power of 2. I can make that substitution. Out goes the y, and in place of the y goes in something that involves an x. Now I have the distance as a function of x. And now, last but not least, I need to simplify this. So let me do some side work over here. And the side work involves us figuring out x squared minus 3 quantity squared. Remember, that square outside the parentheses means I have two parentheses, so I should write them out twice. And then I just distribute like I'm used to doing. This part is no big deal whatsoever. Okay? This is something you know how to do. So, you good? Following with that? Okay, so the distance as a function of x is equal to the square root of x squared plus x to the fourth minus 6x squared plus 9. And when you collect your like terms, you will end up with the square root of x to the fourth minus 5x squared plus 9. And I cannot do any more simplifying. I can't take the square root of them individually, so I leave them alone. Good? Okay, now they could ask me all sorts of questions after this. They could say find d of 0 or d of -1. And all I have to do is plug those numbers in for x and see what comes out for the distance. Agreed? Okay, let's scoot on to another one. So it says a right triangle has one vertex on the graph of y equals x to the power of 6, where x is greater than 0. So remember, when they say x is greater than 0, that means basically I'm dealing with a positive number. And let's see, a right triangle has one vertex on the graph of y equals x to the 6th at the point xy. Okay, so here's where we're speaking about. And another's at the origin. And then a third one is on the positive x-axis. Cool? And they would like us to find the area of the triangle. Well, help me out. First and foremost, how do you find the area of a triangle? Good. The area of a triangle is base times height divided by 2. Agreed? So I need to know the length of the base, and I need to know how tall this is. I need to know the height. So I don't see any concrete numbers for that, do you? Yeah, no. So let's agree on something. Let's agree that the base of this triangle goes from the point 0y to the point xy, and then the height of this triangle is going to go from the point 0y to the point 0, 0. So it looks like we need to find a couple of distances, don't we? We need to find the distance of the base and the distance of the height. Agreed? Okay, so let's go with the base first. We said the base was from 0y to xy, and I don't know that distance, do I? So we're going to have to use that distance formula again. Agreed? So we'll have 0 minus x, quantity squared, plus y minus y, quantity squared. I like what's happening with that y's over there. So basically this will be a negative x squared, and basically this would just be x squared, because when you square a negative it becomes positive, so it's just x, isn't it? So the base has a distance of x. So let me back up. So I can say x. Now we got to find the height. And we said the height goes from 0y to 0, 0. So I guess I need to find the distance of that, don't I? So it looks like we have 0 minus 0. Well, that looks good. Y minus 0. Both parentheses are squared. So it looks like I have the square root of y squared, which would just be y. All right, so it looks like the height is y. So it looks like I have the area of my triangle as x times y divided by 2. Cool? Wonderful. But then they say as a function of x, which means that y is not allowed, is it? Nope. So, not back to the drawing board, but this is my formula for the area of that triangle, and I need it as a function of x. So clearly the x and the 2 are just fine. The y is not okay. So, what do we know about y? Yeah, we know y equals x to the power of 6. So, since y equals x to the power of 6, up here I'm going to have x to the power of 6, which means my area as a function of x is going to be equal to x to the power of 7 over 2. Good? Wonderful. Okay. And again, now they can ask me for the area of this triangle when x is equal to 2 or x is equal to 3 or whatever. Remember, because they said x had to be positive. X had to be greater than 0, which is why they can't say x is negative 2. Cool? All right, let's look at another one. A rectangle is inscribed in a circle of radius 1. And they said, see the figure. Okay. P, which is a generic XY point, is in quadrant 1, and it is the vertex of the rectangle that is actually on the circle. All right? Got it. So, let's look at part A. Part A asks us to express the area of the rectangle. So, help me out. How do you find the area of a rectangle? Yeah, that's length times width, isn't it? Okay, so again, I don't see the length and I don't see the width. So we're going to have to come up with the literal length and the literal width. All right, so I'm going to say this side is the length. So I see we have the point XY, but I don't see that point. Do you have any idea what that point might be? Yes, it will still be a positive X because it's in line, isn't it? Now, the beauty of this is it looks like, since the circle is centered at 0, 0, it looks like half of the rectangle is above the x-axis and the other half is below the x-axis. So if this is the point xy, this would be the point x, I heard you, negative y. And for our width, let's say this is the width. So from the point xy, now I need this point, don't I? Yeah, it's going to be a negative x and a positive y, isn't it? Okay, so we have we have a length and a width that we need to find. So let's go with the length first. Okay? Again, we're going to have to use that distance formula. So we're going to say x minus x, quantity squared, plus, good, y minus a negative y. With me? All right, so it looks like those x's drop out. So it looks like I have the square root of 2y, don't I? Because it's y plus y here. And looks like my distance, or I should say my length, will be 2y. Cool? All right, let's look at the width. So the width is going to be from xy to negative xy. So it looks like, again, I have the square root of x minus a negative x, and then a y minus y. Well, I like that y minus y, don't you? So it looks like it's the square root of 2x squared, because those y's drop out, don't they? Or just 2x. Agreed? All right, so let me move to the next page. Why? Because I need more room. So, the area of this rectangle was x times y. We found, pardon me, let's try that again. The area of this rectangle was length times width. Well, we found the length is 2y. Sorry about that. I wrote the wrong variable. So we found this is 2y for the length and 2x for the width, which gives us an area of 4xy. Cool? But once again, they would like it as a function of x. And if you didn't see that, here it is, as a function of x, which means I need to get rid of that y. How do I get rid of that y? Well, you know I have this equation down here. And if I solve that equation for y, couldn't I get rid of, or couldn't I isolate the y and put the x in its place? All right, so looks like we have a little bit of work to do. So let me get rid of this. So we have just a little bit more space. So since x squared plus y squared is equal to 1, we need to solve for y. So we can replace the y up here. So I've got y squared is equal to 1 minus x squared. Agreed? And yes, square root both sides, which means y is equal to 1 minus x squared, isn't it? Okay. So it looks like the area of the rectangle as a function of x will be equal to 4x times the square root of 1 minus x squared. Here is the area of the rectangle as a function of x. Cool? Yay! Now, they could ask us another question about this, besides finding the area of the rectangle as a function of x. They could also ask me to find the perimeter of this rectangle as a function of x. So, let me get a part B for us. Part B, find the perimeter of the rectangle as a function of x. Well, help me out. How do you find the perimeter of a rectangle? Good. It's 2 length plus 2 width, right? We know that the length was 2y. We know that the width was 2x. So my perimeter formula is looking like 4y plus 4x, or if you allow me to write in alphabetical order, 4x plus 4y. Cool? But they want it as a function of x, which means, that's right, we need to replace this y. And don't we already know why? Yep, right there. So your perimeter of this rectangle as a function of x is going to look like this lovely function right here. Cool? Okay. So here's the thing, if you haven't noticed yet. What we basically do first is we find the formula for whatever we need to work with. The area of a rectangle, or the area of a triangle, or whatever else. And then once I've got that, then I know what I need to do. Sometimes I need to find the distance in order to know what to plug in. And then I can start replacing the y with an x. When I find the variable that, or pardon me, when I find the equation that contains that variable to make the substitution. Good? Are you with me? Okay, let's go for another one. A wire that is 18 meters long is to be cut into 2 pieces. One piece will be shaped as a square. The other will be shaped as a circle. Now, let's look at part A. Part A would like us to express the total area enclosed by the pieces of wire. So, total area, right? Now, I know I didn't finish reading it. Hang in there. What I'm focusing on is we need the total area. And the total area is going to be equal to the area of the square plus the area of that circle. So, question. Since they say that one length of the side is x for the square, how do I find the area of the square? Good. So the area of the square is basically still length times width, which is going to be x times x, which is just x squared, isn't it? So got the area of our square, it is x squared. Now I need the area of the circle. All right, so question. How do you find the area of a circle? Yeah, area of a circle is equal to pi r squared. So I need to know the radius of that circle, don't I? Okay, I don't know about you, but I don't see the radius of that circle. You know what I do see, though? I do see that this circle was formed by this much of the wire. So that 18 minus 4x, what does that actually represent? Because we took that piece of wire and we bent it, didn't we? And now it's making this circle, so it's going around the circle, isn't it? So if it's going around the circle, then 18 minus 4x is actually representing what? I think I heard some of you say it. That's the circumference of the circle. The circumference of the circle is 18 minus 4x. And the formula for the circumference is 2 pi r, isn't it? So, if both of these equal circumference, that means, yep, they both have to be equal to each other. Since they both equal circumference, they both have to equal each other. And we're doing this so we can find r. Okay, so to get r by itself, you simply have to divide by 2 pi, don't you? And I can reduce, can I not? Cool? Okay, so let me go back. So I have got area of a circle is equal to pi times 9 minus 2x over pi, and this is supposed to be squared, isn't it? Awesome. Now, I'm running out of room, so if you allow me to do some side work over here, because I've got more room. So we have the area of the circle is equal to pi, and in parentheses 9 minus 2x over pi, and the whole thing is now squared because the radius is squared. Agreed? Okay, so since this is division, do I have to look at the numerator and denominator together, or can I separate them? Good, you can separate them, which means I could write this as 9 minus 2x squared over pi squared. See what happens? Good. One of those pi's on the bottom cancel out, don't they? This pi and one of those cancels, doesn't it? So it looks like the area of my circle is this wonderful equation. So let's pop that in there. Plus 9 minus 2x squared all over pi. And they wanted it as a function of x. Well, there's nothing but x in there, is there? So the total area is already written as a function of x. So we're totally good on that. Good? What do you think? Okay, loving it. Now, got a question, one more question for you on this one. So I'm going to throw a part B at you, okay? I want to know what the domain of this area will be. So part B, the domain of the total area. I'm like, well, how do I find that? You know, there's a couple ways you can do this. One thing I know is this. This wire is 18 meters long, right? That's all I got. And I know part of it makes the square, and I know part of it makes the circle. Now, here's the deal. The square can't use more than 18 meters of the wire, right? And it can't use less than 0 meters of the wire. Agreed? Well, isn't that the same with the circle? The circle can't use more than 18 meters of the wire, and it can't use any less than 0 meters of the wire. So to be honest with you, it doesn't matter which one of these I look at. I'm going to get the same answer. So, okay, so let's use the information of the square. I know that the perimeter of the square, which was 4x, has to be greater than 0. It can't be equal to 0, because if it's equal to 0, I don't have a square. And it has to be less than 18. It can't be 18, because if it is 18, then I don't have a circle. So, if I divide everything by 4, this is still 0, less than x, less than 18 over 4, right? Which means x has to be less than, or pardon me, x has to be greater than 0 and less than 9 over 2. Do you agree? Now, let me prove it to you. Let me use the information for the circle. The perimeter of the circle was 18 minus 4x. Again, that circle perimeter or circumference has to be greater than 0. If it's equal to 0, I don't have a circle. But at the same time, it has to be less than 18. If it's equal to 18, I don't have the square. So first things first, we have to minus that 18 off of all three sides, don't we? Agreed? Okay. And then we have to divide by that negative 4, don't we? Do you remember what happens to the inequality signs when you divide by a negative? Good, they flip over, which means I have a positive 18 fourths less than x. Pardon me. What did I just tell you? And I didn't do that myself. 18 fourths greater than x greater than 0. I'm going to switch this around because 0 is smaller than 18 over 4, isn't it? So 0 is less than x less than 18 over 4, which means once again x has to be less than 9 over 2 and greater than 0. So it doesn't matter which object I focused on. I get the exact same domain for the total area. X, which represents the side of a square, that length has to be greater than 0 and less than 9 over 2. If they allow us to have a decimal, then you can say x is greater than 0 and less than 4.5 if they allow us to have the decimal. Cool? Does this make sense? Good. I need you to know it doesn't matter which of those two objects you focused on because the domain's exactly the same. All right, let's scoot on. All right, so we have a wire of length 6x and it is bent into the shape of a circle. Sounding a little familiar. So they would like us to find the circumference of the circle. All right, so let's deal with part A. How do you find the circumference of the circle? Yep, we just did it, 2 pi r. Agreed? Question. This wire being a length of 6x and the entire wire is bent into the shape of the circle, what does the 6x actually represent? Yeah, the 6x actually represents the circumference, doesn't it? Okay, so here's what we know. The circumference of the circle is 6x. And to find the circumference, I need to know r, don't I? So boy, this sounds like the last problem we did. So I know that 6x must be equal to 2 pi r, which means if I'm solving for r, that means it's 6x over 2 pi, isn't it? And r would be equal to 3x over pi. Got it? That means that our circumference of the circle will be equal to 2 pi times 3x over pi. Okay, so that means when you plug that in, you just get the circumference as 6x, don't you? Well, that makes perfect sense, doesn't it? It looks like we did a lot of work for nothing because the circumference was already 6x based upon this information we figured out right here. So the circumference of the circle with respect to x is 6x. All right. That was kind of a roundabout thing, wasn't it? Okay, so let's look at part B. Part B wants the area of the circle. All right. So how do you find the area of the circle? Good. Pi r squared. But they said write it as a function of x. Well, we found r, didn't we, already in the last part? We said the radius was 3x over pi. So if we plug that in, Looks like it wasn't for nothing. Looks like we actually needed that radius. It looks like it's pi. And again, since there's division between the numerator and denominator, right? Both of them are squared. Looks like one of those pi's cancel, don't they? Yeah. Which leaves me 9x squared over pi as the area of this circle as a function of x. Cool? All right, so this problem was a little bit easier than it seemed. Part A, they said find the circumference. Well, the circumference should have just been 6x, and we proved that it was. The second part said find the area. Well, we needed the radius, so it was a good thing we did this work anyway. Okay, last problem. Let's check this out. A semicircle of radius 2x. Okay, so this is radius 2x. Which means this would be a 2x also, wouldn't it? And over here would also be 2x, wouldn't it? Because that's all part of the circle. It's inscribed in a rectangle. So the diameter of the semicircle is actually the length of the rectangle. So, help me out. Do you agree that this side was a length of 2x from the center of this circle out? And this side is a length of 2x from the center of the circle out, isn't it? But from this point to this point is the diameter of the circle, and according to them, not only is it the diameter of the circle, but it's the length of the rectangle. So I guess my question to you is this. Got the length of the rectangle? Yeah, the length of the rectangle is 4x. All I have to do is add those together, don't I? Okay. So, I know, I jumped a little bit ahead, but sometimes when they give us this information, sometimes it's not a bad idea to just keep going with it and at least get something down. And maybe we need it, maybe we don't. We'll see. So part A wants the area of this rectangle as a function of x. Okay, so the area of a rectangle is length times width, right? But they want it as a function of x, don't they? Well, we already found the length was the length was 4x, wasn't it? We already determined that length. Now what we need is the width of this rectangle. So let's check it out. The width of it. You know, here's what I'm seeing. I know that this is the radius of the circle. But isn't this also the radius of the circle, center out to its arc? So this is also 2x, isn't it? Doesn't this side parallel this side? So if this side is 2x, wouldn't this side also be 2x? Well, isn't that the width of the rectangle also? Yes, it is. So my width of my rectangle is 2x, which means the area of the rectangle as a function of x would be 8x squared. Good? Hey, that wasn't too bad. Okay, let's look at part B. They want the perimeter of the rectangle as a function of x. Okay. We've spoken about perimeter before of a rectangle. Perimeter of a rectangle is 2 lengths plus 2 widths, right? But they want it as a function of x. We already know the length, don't we? Yep, right here. That was 4x. And we already know the width, don't we? Yep, that was that 2x. So, looks like I have 8x plus 4x. Looks like the perimeter of this rectangle as a function of x is simply 12x. Not too bad, huh? Cool. Okay, so here's the thing. Once you find all these wonderful functions, then it's easy for them to ask you all these follow-up questions like, well, what happens if x is 7 or whatever? It's easy to plug in to find the area and the perimeter. Good? Okay, so you have fun with this stuff, and I'll catch you on the flip side.